once we have the recording created, then we're ready to create a recipe. So we'll go up here to start training, and we'll select a recipe that we created earlier, start training. And what we're seeing now is that video. And we have the kind of standard playback buttons here at the bottom, allowing us to move the vial into the field of view and go frame by frame as needed. What we're wanting to do first of all is show the computer vision system where the vial is so that it knows what it's supposed to be tracking, and generally just put the lines around the sidewall area of the vial is what we typically do. And then this yellow line over here indicates where it will stop tracking the vial as it moves across the screen. And so we're going to do this for each one of the cameras. Here's the S camera. And finally the T camera. And just kind of get it generally close here. It's not too fussy. All right, now the next thing to do, now that we've got the tracking model defined, oop, forgot a line here. There we go. So all those boundaries are set up. Now what we want to do is we want to add inspection cells or regions of interest. So each one of these regions of interest defines an area within the tracked vial where a unique machine learning model will be built. And I just put one here in the big sidewall area. This is pretty typical to put one right here to start with. And as you can see, when I click on this cell, there's all kinds of settings associated with it. For the most part, you can just take the defaults here. But as you gain experience with the system, there are some kinds of more sophisticated things you can do, like setting the size of a particle that you want to detect or allow. And so we'll just leave those at the defaults. And as we add more cells, what we're generally doing is we're looking to add inspection cells to areas of the vial that are homogeneous across all compliant units. And so since the cap area is so different from the sidewall area, I put two separate cells there. And I may drag this down here into the crimp area so I can see the crimp. And I'll add another one here in the neck. And it's actually perfectly fine to have cells overlapping. As a matter of fact, it's usually a good thing to have a little bit of overlap so that you ensure that you have that 100% coverage. And I'll put maybe another one here in the shoulder area. And so this just takes a little bit of experience. After you've done it a couple times, you'll know what to do. This one down here is pretty common for us. We'll set an inspection area down here uh, where the product is, or if there's liquid, and we'll set one right across the fill line. And this is one of the ways that the machine learning model can determine the normal fill level and all the different variations of that fill level. You may decide for a given vial type that you want to use the mirror and also inspect the base of the vial. I won't do that for this one. All right, and now we do the same thing for the P camera. I'll add some cells on here. And once we're done adding cells, I'll just add some more here. after the video, and then we're ready to start training. So as we see the recording start to play through AVIS, the first thing that's happening is it's building a tracking model that shows the speed of each vial as it moves through the inspection area. This is important because in the recipe, we want AVIS to be able to know that the vials are being processed in a batch run at the same speed at which the training was done. So here we have the completed tracking model, and now you see as the vials are moving through the screen that the cells that we added prior in this video are now tracking across the vial and getting a full 360-degree rotation of all the areas that are being inspected. Over on the right, you see a bunch of learning curves. These are the learning curves for the machine learning model that's being built. In general, what you're seeing along the horizontal axis is the number of inferences. So this is going to very quickly run into the millions. And what you're seeing on the vertical axis is the number of clusters that have been created. Each cluster is a version of normal. And so here we have over 800 clusters just for that one inspection cell that here is on the sidewall and also overlapping with the fill area. So these are extremely complex, high-dimensional, unsupervised machine learning models that capture the normal variation that you see in the pharma vial that's for which the recipe is being trained. So I'll just let this run for a moment here. I'll also make a comment as you look at this that the deposition of powder, the shadowing in the molded glass makes this an extremely complex and difficult vial type to create an automated visual inspection system for. Rule-based systems basically won't work with this kind of a vial. The unsupervised machine learning approach is really ideal because it starts from a blank slate and it assumes that the vials that are passing through these regions of interest are compliant and that they're showing things that are normal and acceptable. That model then becomes the reference for the actual batch run recipe that will be used to detect defects during real time. Okay, here we are at the end of the recording. At this point, all the vials have been processed through, the machine learning models are complete. And so the last thing to do is to assign a name to the recipe. And then once we've saved that, then this recipe is frozen. And this is what we'll use to do our validation with defect sets and additional holdback units.